Now, first of all, this motor is insane. The truth about these engine swaps that the internet doesn't get, and a good number of people have LS swapped them. This is the mighty BMW M70 V12. Without doing a whole lot to them, they can easily rev to 8,000, 9,000 RPMs, and that allows you to put the motor properly centered in the car. And just show you guys the basics as to what to think about when you're giving consideration to engine swaps. What's up, people? So today I've got 4 different engines. We've got a Viper V10, we've got a Huyabusa engine from a motorcycle, we've also got the Honda K series that just came for the Genius Garage IndyCar swap, as well as the nastiest small block Chevy derivative racing engine you've ever seen. Individual throttle bodies, electronic fuel injection, damn thing's putting down like 900 horsepower, naturally aspirated. So I wanted to open this up, but we're gonna go over this today, like what engines do you use for your swap? Everybody's talking LS swap, people do things with motorcycle engines, so really I kind of want to go over these differences and just show you guys the basics as to what to think about when you're giving consideration to engine swaps. I hear all the time people are like, well, why don't you do this? Put a V12, put a Lambo engine, Doritos, you know, and they all go nuts, you know, even Porsche flat sixes and stuff. But many of these engines simply will not work for your build or frankly makes any sense at all. And there are some people out there doing totally zany engines that just aren't really a good idea, but it's sort of fun because it's not a good idea, but because it's not a good idea it means I don't want to do it. So let's just open this up and I want to show you guys some fun things. So this engine here, this one belongs to Genius Garage. Genius Garage is the nonprofit public educational charity where I mentor some young engineers and techs and stuff with. And thought a really amazing project for them this year would be to take this mid-1990s IndyCar chassis right here, which you guys can see. And as a note, this is the transaxle. I should have probably pumped that up before I did that. This is the transaxle or transmission. And if you want to take a close look, and this is something other people don't realize, one of the difficult aspects of this build is the engine has to be a stressed member. As you guys can see, there's no frame here. That's because the engine has to become the frame or the chassis. Now, the engines we're utilizing are off production-based cars where they're not a stress member and they weren't designed for that. So we have to do things to the engine as well as some added little chassis members to make that work, and it's very difficult. So I just want to make a note of that. And some other people were saying, well, why don't you take the transaxle and flip it over? Can't do it because this transaxle is also the chassis, and that's where all the suspension members connect. And you can look at this here. So that's an example. So right here, we've got this Honda K series motor, and the very fascinating thing about it is this. One, in a moment, you're gonna see, and if you wanna pan over there and look at it, they can still hear me. Over there in the corner with the beautiful silver throttle bodies at the top, that is the small block Chevy push rod derivative that came out of the car. You know, it's a pretty hefty beast. It's largely stressed with some added things to support it. And that engine, naturally aspirated on gasoline, was making 840 horsepower at the wheels before it was finished being tuned. So it's very nasty. But the difficult things about that Chevy is it makes a lot of heat. It's hard to cool through the IndyCar cooling system, which was originally designed for a methanol engine, which runs a lot cooler than a gasoline engine. And also, a pushrod Chevy does not rev that high. Gross. I got freaking grease on me and I thought I was bleeding all over the place. Fortunately, I'm not bleeding. Welcome to Working on Cars. So that engine does not suit this well because this transaxle originally designed for something that revs very high. The original engine's revved to like 12,000 RPMs, made a lot of horsepower. That makes a lot of horsepower, but it only revs to 8,500 kind of safely, 9 grand maybe if you're crushing it. Now, we decided to look at this Honda K series 4-cylinder engine. Stock, they were used in Hondas and Acuras and all that. In the United States, the better ones were making right about 200 horsepower, but they can rev. So without doing a whole lot to them, they can easily rev to 8,000, 9,000 RPMs and even more if you do some stuff to it. And they're readily available and cheap. This engine here looks to be a rather nice example, reasonably low mileage, making about 200 horsepower, and it can do that forever because it's a production-based car meant to go a couple 100,000 miles. It was less than $1,000 with all these sensors and everything attached. Now, obviously in racing, you're gonna wanna take off these headers and do some neat things. You might even go standalone management, or you might go with the normal, and you can walk around and take a look while we're talking here. You can go with the stock ECU, etc. But as an example, even at 200 horsepower, if you're able to take this engine and put it into a proper racing chassis and racing car, that's going to be a fast car on a road racing track. As an example, with this car, with an engine like that, and it's not going to weigh much more than 1,000 pounds. And even though this car was originally designed for a high horsepower going really fast, it still makes a ton of downforce. So you could easily take some of the downforce off of it, and you're going to end up with a very strong, robust, and safe open wheel car for lapping days, vintage things, etc., with great tires and wheels and brakes that are going to last forever with that power plant. So it's a less expensive way to make an awesome car and also showcase, Indianapolis history without building something absurd that requires way too much support. The other thing neat about it is it would be possible to make the side pods and everything removable to make basically a center seat Can-Am type car to run in like NASA Unlimited. So I think this is going to be a really good program for the students. But the other nice thing about the K series here, and if you want to kind of come in a little closer, I'll show you. I mean, obviously you got the block down in here. It's got a timing chain rather than timing belts. Here's your crankshaft output for the serpentine belt for the accessories here. It's currently a wet sump system. You can see all the oil is held down here in the pan, which is not ideal for road racing for all the braking and turning forces. The oil sloshes around, becomes difficult. You see oil filter. Here's the exhaust headers, and then come back here, we'll take another peek. And this is a big thing with regard to doing engine swaps. This is like kind of like a stock flywheel. Your clutch would bolt on, you'd have a ring gear, and here's your starter. Now the problem with this is rather large. And so if you look at this here, from the center line to the bottom of where the radius is about this big from the center line to where the teeth would be. So even if you put a lower profile dry sump oil pan on it to get it lower, this is a concern. So let's take this radius measurement. I want to show you guys the bell housing of this. So this is a prime thing you have to look out for when you're doing an engine swap. See if the camera person can get around there okay. The problem is it has a tiny clutch designed for racing. And if the radius is this big, that can't possibly fit inside there. You see that? So even if you made another spacer just for the flywheel, excuse me, just for the flywheel to be there and you had the tiny clutch on it, it's still quite large. And if you notice this, look, that flywheel ends up coming a few inches below the bottom of the car. And this is the bottom of the car. And you have like a thin layer of carbon fiber for your Venturi tunnels. Now, the difficulty with that is, yes, you could raise this up, but that suspension was not designed to have that kind of ride height. You could also raise it up here, so you'd start making kind of a Frankenstein car, and then other people think, well, why don't you put on taller tires and then, gear it differently? That's not a half bad idea, but that kind of throws things off too, and nobody really makes tires that are poofier than this, designed for a road racing car, especially one that makes that kind of downforce. So in this circumstance, the reason it's so difficult, and I wanted to start with the more difficult ones, and then we're going to turn around and look at all these, is you've got constraints. So you have to think about the engines that most reasonably can work. Now the other aspect about the K series, two things. One, its physical size. It's not very long. And the beautiful thing about that is it will fit inside here, and we'll be able to build big bulkheads and still have room for all the ancillary pulleys and such for the, the alternator and the serpentine belt, as well as another pulley here to run the dry sump oil pump, which is really nice. Whereas the small block Chevy in it that was much too longer, and when the small block Chevy went in this chassis for the American IndyCar series back in the day, it extended the wheelbase about 3 inches, which is okay, but it's not ideal. The beautiful thing about this motor is we're going to bring the wheelbase back to where it was originally intended for the chassis. Now lastly, this engine making about 200 horsepower in a stock trim, and it can do that for a very, very long time. This chassis and this gearbox and everything was designed for much higher loading, much higher horsepower, torque, and stresses than that engine is capable of doing. So the beautiful thing about that is you're actually understressing your chassis. So it's going to be something that lasts forever and is safe and awesome, which gives you the other opportunity for Genius Garage to build a seriously potent, psychotic engine. Now, a lot of people just like to throw turbos on it, crank the boost, and think it's not going to blow up. Well, they're going to blow up. So you can potentially, create 50% more horsepower, double the horsepower, but how long is it going to last? So I think this is really neat because this engine's so inexpensive for one that runs less than $1,000 that the Genius Garage students can experiment with their own tuning, actual engine tuning, and building for the internals and things that need to happen for it. And even if we hurt an engine in the future, doing the best job we can to not, it's not the end of the world. So you could easily build a 450 horsepower engine, 600, 700, go crazy, and this car is going to be able to support it. So that's really neat. I'm kind of excited about that. Now the other thing is, so this is an inline production-based car engine. And over here, and I'm going to move this sandrail here so you guys can see it. Let me just not kill all the cars. Okay. Right here, you guys can see this is a Huyabusa engine right here out of a Suzuki. Now these guys are also making the better part of 200 horsepower, but it's smaller displacement than, say, the Honda. So for it to make that kind of horsepower with much less displacement, like I think they punch out like 1300 cc's, it has to rev higher. So this is a 10,000 RPM motor, whereas the Honda over there in stock configuration is like 7,500 tops maybe. But the Honda production motor will make more torque. This makes less torque, so you have to wring it out. The neat thing about a bike motor, and I'm going to show you guys right now a bike motor in a car. The neat thing about it is it's got its own gearbox, which is sequential shifted dog box. So it's very easy to wop, bop, bop, bop. And if you put in a spark interrupter or something like that, you can keep your foot flat to the floor on the upshifts and just pop it into the next gear without the clutch, because a spark interrupter, you know, kills the ability for it to make power just for that instant, and you can mesh the teeth and keep going of the gear. So that's something really neat about a bike gearbox. But the problem with bike gearboxes is you're not making a ton of torque. If you want to start making more horsepower than that, you're going to start stressing them out. And I know there's dudes that make tons of horsepower and everything, but I'm telling you right now, when you start doing 50% more power, 100% more power, and more of an engine, wasn't originally designed for that, and some of them do better than others, but you're stressing them out, eventually they're going to blow up or hurt themselves, or you're going to spend a crap ton of money to do it. Don't be fooled by the idiot YouTubers like, slap a junkyard turbo on and make 14 times more horsepower, yeah boy. Do you really believe everything you watch on TV? Please don't. So that's something but they're nicely self-contained, and there's a lot of good aftermarket for this. This has electronic fuel injection, and by the way, these velocity stacks right here from a Huyabusa is a great used source to get individual throttle bodies and create your own stack of kit if you're building your own for a production-based engine. So here's another example, and let's take this opportunity to now show a motorcycle-powered car build and what's going on. So this here is the Formula One hot rod that I'm building, and first of all, I have to say, none of the chassis is triangulated yet, and only have I picked up the points. So for all you trolls that are going, I don't like his welds, it's not triangulated, that's stupid. Just don't, it's not done yet. Okay, so you can see the bodywork here, the carbon fiber piece over top of it. And maybe it'd be easier if you went to that size so you can see the chain drive and just go back just a little bit. Here's a Huyabusa motor, and this particular one is a dry sump racing setup one. Very, very nice, kind of expensive motor that came out of a Radical. Radical is a beautiful little open cockpit race car built in England, and they are motorcycle powered. Now, those things are just smoking fast because they're lightweight. Now, it's not always about making huge numbers of horsepower. Everybody likes to do that on the street because everybody on the street's an idiot. You can't really race there anyway, so they just need bragging and flexing and big swinging you-know-what rights. But truthfully, when you're actually racing, you don't necessarily need that much horsepower, especially if you have aero, because you can get around and you already have something that's fast. So this is an incredible engine, and currently I'm building this rear space frame, tubular space frame chassis to create the Formula One hot rod. You know, you got the sequential shifting box that you can utilize on the street, and you guys can see right here the chain which is driving this differential. You can see the differential is not mounted. I literally have it held up by safety wire right now. I'm doing this so I can get all the spatial considerations when I do my final triangulation and all. But, and as a note, I want to give you guys a plug here. So this differential right here, really an insanely nice piece and is absolutely paramount for building a motorcycle powered car where you're using the chain to drive it in this conventional manner. This is made by Taylor Race Engineering down in Texas. Current sponsor, guys, look them in the description. Since 1975, Taylor Race Engineering down in Texas has done just that. So whether you're looking for dog rings and straight cut gears for your road racing car, or you are on a college Formula SAE team and you guys need a chain drive differential and trapeze, this is the place you got to call, guys. Or go to the internet at taylor-race.com. You can see a link in the description below, and I hope you enjoyed today's video. This is a chain drive differential specifically made for applications like that. So it has this beautiful trapeze here, so I'll be able to bolt it in, tension it, and the biggest thing that's amazing about this is the sprocket is hugely offset over here to the flange, and that allows you to put the motor properly centered in the car. There's a lot of people that budget take a differential out of a production-based car, put a sprocket on it, seal it, fill it full of oil and grease to make it work. But the problem is your chain ends up being over and then your engine has to be offset. So I just want to throw that out there to you guys. This is really great. So check out Taylor Race Engineering. But this is an example of how you can put a Huyabusa engine in a vehicle. If it's chain drive, it works great for a mid-engine configuration, but the downside is you don't have reverse. So if you want reverse, the easiest way really is to come up with a little electric motor, like a starter motor, to either drive a little ring gear on the back of the differential, which I'm looking at doing, or something that comes in from the side and obviously drives it in electric and reverse as long as you have the car in neutral, the clutch pushed in. So that's where we're going with this one. The other way to take a motorcycle engine, if you want to come right over here and look, this is the output shaft of the motorcycle engine right here. That's the cog. So you guys can find, if you look online, there's a lot of adapter kits and such where you can put a flange, bolt it right onto here, and run a drive shaft right off the motor to drive a conventional differential, or even to a gearbox or something like that if you like. Now, if you do that, you're going to have to take this motor and turn it in 90 degrees. It's going to be in longitudinal, which is kind of cool. The only downside of that is, since it's way off center where the drive line is, your engine's going to be off center, which isn't necessarily bad, especially if you guys think of it. So this motor will be on the more to the left side of a vehicle with your drive shaft here. If you do that configuration, you have a drive shaft, it actually works well in some ways. So if you have a right-hand drive car, then your motor's on the left and kind of offset the weight if that's what you're going for. But if that's not what you're going for, it's a little bit frustrating because it's off center. So that's a compromise if you're going to do a build like this. But in this circumstance, I was able to get it in as it would be in the bike. It's going to be partially stress member with the frame with all that regard. And because of this awesome differential through Taylor Race Engineering, I was able to center the motor and have really good quality parts. And then obviously you guys can see I'm starting to get all the original A-arms and suspension bolted to the space frame as it would have been on the original IndyCar transaxle, which is right here. This is full of Hewland gears, has a conventional ring and tight pinion, limited slip differential, and dog engagement straight cut gears. And this is a magnesium alloy case. The reason I'm building a space frame with the Huyabusa motor is because that's the coolest hot rod that's gonna make a really fast, really lightweight car, not much more than 1,000 pounds altogether. And the beauty about this is all the suspension points that bolt to the stress member original IndyCar transaxle there bolt to this tubular space frame in the same way. So if in the future the owner ever wants to get rid of this drivetrain and put in something bigger or conventional, the car can be reconfigured back the way it was. So I want to show you guys last the more conventional engine swap things over here that we're going to showcase and get into. I don't know if I can drag this. Oh, that's not connected. Hooray. I wonder if I can, camera guy, can I drag this? Yes, I can. I am a beast. I win. Okay. So here we go, guys. Here are two really awesome, big, nasty American motors. Pretty good examples, I think. So this is a small block Chevy derivative. Now, first of all, this motor is insane, and I'm going to get into it in a moment. You guys can probably imagine this is pretty insane. We're not going to put this in a street car. This is a Generation 2 Dodge Viper 8-liter V10. This is out of a production-based Viper. Typical for a production-based car, it's soft. Production-based cars have to last a few 100,000 miles, unlike a race car that gets rebuilt often. So compression ratios are lower. There's a lot of things done in regard to them to last. They're wet sump oiling system versus dry sump. Dry sump is where you have a big pump that sucks the engine out of everywhere in the oil, and one little pump just to put the oil back in. So you can get all the oil out really quick, put it in this beautiful tank to separate air out of it, and then pump good oil back in. It's complicated, but it's sort of necessary when you're road racing things or doing higher RPM. You know, you also see all the ancillary stuff. The heavy, here's the air conditioning unit, the power steering pump, as well as the ancillaries, everything on there, and then there's some tubular headers. Now this engine, I'm going to do a mid-engine configuration with the engine behind the cockpit. Now the tough part of that is you have to have a transmission that also houses the differential, which maybe you can come over here and take a look. That's called a transaxle, where the transmission and the differential are one, you have a transaxle. This particular one is out of a Porsche twin turbo 996 and was frankly pretty darn expensive, but I needed it to be able to hold the power. There's a lot of transaxles you can get cheaper, but they're not going to hold the power. You know, if you're really nice to them, you might not hurt them, but you're not going to be able to do anything cool. So this, I'm still not going to sidestep the clutch at 6 grand like an idiot or power shift it like I'm trying to make a muscle car go faster in 1965 because it's already going to be fast. But it can at least hold the power. I can put a limited slip differential in it, drift and do crazy things as long as I keep it cool. So this is a difficult thing. Also here you can see the adapter plate, and this was done by Kennedy Engineering Products. You know, and there's other places out there, like for instance, I'll show you guys the King Zero over there has a V12. I had to find somebody that can make me an adapter because the King Zero mates the BMW V12 to a Boxster transaxle. So this is going to go in my Jabberwock build, or the Viper GTP build. Now this engine here, this is a full race, as it's called. I know the guys that work at Jegs and Summit can't stand people walking and going, I want full race, because people don't know what that means. But this is a racing engine. It's kind of absurd. And I'll show you some things that make it terrible for the street. One, it actually has an alternator on it, but here is your dry sump oil pump right here that's driven off of this. It actually has a hard mount dampener. And you can see that this is very, very low, the center line of the crankshaft to the ground. It has a dry sump oil pan on here, which very closely comes to the bottom of the crankshaft. Also, you'll also notice this is your cam pulley, and the cam in this engine is converted from being a timing chain to this timing belt, which allows you to finitely adjust the timing of the camshaft. So really nice, precise things here. Also, it has this thick billet aluminum plate bolted to the front of the motor, which creates the engine, allows it to become more of a stress member, because these pickup points at the top here, as well as the pickup points at the bottom, this is how this engine used to bolt to the IndyCar carbon fiber monocoque in the front. And then this engine became the chassis, or became the frame as it bolted to it. Obviously, you guys can see a lot of other zoomy stuff, custom built, coolant overflows, you know, your coolant tubes and things going there, even a little cooler for the alternator. These massive and insanely cool headers that were custom built specifically for the IndyCar, basically to create a carbon fiber oven. It's kind of annoying. It's too big of a motor for the car, like physically. Also, you can see the teeny tiny clutch here. This is a Quartermaster one. And it's actually a 4.5-inch clutch disc. There's 3 of them. This is good for holding about 800 horsepower, but it's very tiny. And the reason this is only really good for racing is this would be garbage on the street because there's no rotating inertia. As a note, stay right there, camera guy. Actually, you're going to have to come over here and make my life a little easier. This under here is the original bell housing for the Dodge Viper. And that is how big the clutch was. So this dimension here is the radius of the clutch disc of the original one on the Viper. Look how much bigger. The original clutch would have been this big, just the clutch. The flywheel on Dodge Viper is that big. It's a lot of rotating inertia. So not only does this not have a flywheel, so you can't even put an onboard starter on it because look how low it is to the ground. You could put a tiny ring gear here, but then that would be more difficult to start. And then where are you going to mount the starter? There's nowhere to mount it. So on the IndyCar, it has to have an auxiliary starter coming in from the back, which is frustrating. And actually, that particular IndyCar transaxle starter was never designed to turn over a motor this big, so it's going to be prone to breakage. Another reason why it'll be nice to put in the Honda K series. It should be okay with that auxiliary starter. But this little guy here has very little rotating inertia, which is great for lightning fast RPM changes, throttle response, etc. Throttle response is kind of pointless in road racing because you're always going as fast as you can. It's not like, well, I need to pass this guy on a 55-mile road. I hope my engine goes. No, it's not like that. It's like you're always going fast. But it's very whoop-bam, 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 wham when you're changing gears. Very precise, very crazy, and also difficult to get out of the pits. This clutch with no rotating assembly with very tall gears, as you typically have in a race car, with a first gear able to go 60 miles an hour or more, makes it very, very, very difficult to just get it out of the pits reasonably. And no, you're not necessarily just going to always dump the clutch and do a giant burnout. So that's an example that makes things difficult. You guys may not experience that when you're building a, doing an engine swap, especially if it's an LS and something. But I just wanted to show you guys some extreme things that are going on. One thing you got to keep in mind, and in the future I'd like to show you guys like a Porsche Flat 6. I think the door's open. I'll show you one. There's one outside rotting. And rotaries. Pick an engine that you enjoy, but pick an engine that has the right characteristics for the chassis platform that you're going to put into it. YouTube is all about sensationalism and doing psychotic things, and most of the things people are doing are terrible. Like, I know people like them and they're fun. Oh, it's so much fun. I'm going to put in this tank engine in a Mazda Miata. Durr. You have an engine that weighs 4 times as much as the car. It's going to be crap. Like, you know what I'm saying? So pick something that's cool, that's going to be well matched. And let me give an example of an engine swap, and camera guy, maybe you can come over here. This car, if you guys haven't seen it, is my King Zero build, really cool. I got inspired by an old prototype from Italy. But instead of a tiny little 4-cylinder engine, this is the mighty BMW M70 V12, typical to the late 80s and early 90s. It's getting dirty because it's been in here while I've been creating it. But here you can see the adapter plate, which adapts this to the Porsche Boxster transaxle. Then you have to have a custom flywheel because the flywheel has to mate to the engine, which is BMW, but your clutch has to be Porsche to mate to the Porsche transaxle. So you need that flywheel that can adapt your engine to your clutch and then work in that regard. And then you need an adapter. So there's quite a bit of engineering and machining going on with that. But then you have the opportunity to build your dreams with an engine that's cool. Now, in this regard, the Porsche Boxster transaxle doesn't hold tons of power. But let's be honest, the BMW V12 from the early 90s, if you're not kitting it out, race building it and dry sumping it and spending ungodly fortunes on it to just make a bunch of power, it doesn't really make that much power. If you're reasonably nice to the transaxle from Porsche, it's going to be able to handle it just fine. So, and with a car like this that's absurd, it's going to be a cool show car, sports car, it's going to be very well matched, it's going to sound great, it's going to last a long time and be a lot of fun. So for me, this is not the time to get silly in building lots of horsepower. If I really wanted to make lots of horsepower, I'm going to be perfectly honest, I would have put a GM LS derivative in because there's no engine that is a cheaper bang for your buck to make power than an LS. And there's lots of things out there available for it. But since this is kind of like an Italian prototype art sort of thing, doing a V12 is really the way to go and a lot of fun. And then lastly, I want to show you guys a Porsche Flat 6. There's one outside here rotting away because it was blown up and it was junk and I wasn't even going to deal with it. And actually, the Porsche that I cut up to use the suspension for the King Zero build, as well that transaxle, is the one this engine came out of. It was already blown up, hence why I got the engine or the car so cheaply. But a number of people have said, why don't you put a Flat 6 in the Indy car? So here's a Porsche Flat 6. This is a water-cooled one out of an early Boxster. You can see your clutch and your flywheels right here. But a first example I want to show you guys. Right now it's sitting on the headers, okay? Look how far the center line of the crankshaft is from the ground. Like that's huge. There's no possible way this could have worked in the Indy car because in the Indy car, the center line of the input shaft to the bottom of the car is that far. So right here, the ground level in the Indy car would be right here. So you'd literally have all this stuff under the ground. There's no way to put it up in the air, which is kind of sad because actually this motor would be really great for something like that because it's very low, the cylinders come out, and it's short. So one example y'all have to think of, especially when you're doing something mid-engine, is how wide your engine is. Maybe if you come over here and look down, you'll see it. This engine, the easiest, most like toy Lego builder way to see is 1, 2, 3 cylinders long. And there's ancillaries and stuff. It's not very long, okay? So the Honda K series, even though it's 4 cylinders, really isn't a whole lot longer. But then you get a GM, you know, like a Chevy V8. Well, it's 4 cylinders, but it's fatter. And then you get the silly Viper engine, which is 5 cylinders and fat, and it's like that long. You know, it's huge. So you got to think of the spatial considerations, like the width, the height, the length, how fast does it spin, you know, what characteristics does it have, can you cool it, where's your exhaust going to end up? So like on this, the exhaust comes out the bottom. Your intake stuff is on the top that's been removed. And then you got ancillary stuff. And generally speaking, you all have to realize, and come on back, we'll go back inside, that when a car company has spent hundreds of millions of dollars over decades developing an engine and ancillaries and transaxles and stuff, you can bet the farm that they've done a better job than you can engineer it. So when in doubt, or when possible, use something that's already existed that works well for your application. And when you do have to modify something, as in the case of the Honda K series, you see, we're going to have a dry sump oil pan down here to get rid of this because the oil sloshing would never work for something that can corner so well. We also have to make this more stressed. So if you want to come over so you can see, poor camera guy's doing the best he can. We ordered actually from England, found a place that casts a dry sump oil pan that's very narrow, so we'll be able to get this engine real low. It's very thick and has mounting ears. So that oil pan then can become a stressed frame member and bolt to the front and the rear and help strengthen the engine from torsion. So the engine will start being able to be used as a partially stressed member. So that's something we're already going to order because they've developed it. It's been in lots of race cars before with success. So if the cost makes sense, cost and time, then utilize something that's already existed. The truth about these engine swaps that the internet doesn't get right now from looking at all these YouTubers is it's really effing hard. Even the easiest engine swap is still really hard. So if you get into something crazy like this Viper V10 engine on a transaxle in a mid-engine car, where I'm just lucky there was an adapter kit for it, you know, or building a Huyabusa motor and building your own custom space frame, this is a little crazy. This is not engine swap normal territory. So get into it. And actually, as an example, what I'm doing here is kind of just like a massive, insane, super expensive Formula SAE car on steroids, if you look into that. But as another example, so Porsche 944s, great car, 4-cylinder engine, doesn't make a lot of power. And a good number of people have LS swapped them. You can actually get a GM LS engine to fit in a 944, but it does have its share of problems. It'll fit, you can cool it. It adds maybe 100, 150 pounds more weight to the front. Not bad, considering you're making a crap load more power. But the biggest inhibiting factor with putting an LS engine in a 944 is the transaxle. Because a 944 does not have a conventional transmission connected to the engine, like right here. It actually has a transaxle in the rear. All of the gears, your gearbox, and your differential is one assembly in the rear. And the ones put in the 944s were designed for a 4-cylinder engine. And there were some with limited slip differentials and a little bit heftier in the later years when 944s became 968s and 944 turbos, or 951s as the Porsche snob community like to call them to inflate the prices. Oh, you know what I mean. They're a little tougher, but now you got to spend a bunch of money on a transaxle. So you have to weigh these items and if it really makes sense, because you can spend a couple of years putting an LS engine in something like this. And then what you're going to end up with is a car that's a little delicate for that and maybe not as well positioned. And it could be really cool. And if you like that, that's great. But as an example, a Marine buddy of mine found out, and camera guy, go over there. So he got a 300ZX and had an LS in it, and he spent like a year making it really good. But the sad thing about it is, when he considers the money and time that he put into it, when he was done, he finally said, dude, you're right, I should have bought a Corvette. Because as an example, as a production-based car, a Corvette, pick your poison, whichever generation you want, was designed to have a V8 engine in them. They already work. You can get them cheaper, and then you can just make it be what you want to be. So my last parting thought to you when you're considering doing an engine swap or a car build is, if you want a 944, get a 944 and enjoy it. But if you have a 944 and you really want a V8 car because you want the power and all, that doesn't mean you should take something that wasn't designed to be that and create it. Maybe you actually need to just get a Corvette, or maybe you just need to get a Viper, and then you can make it what you want, and then you can use your time to do something else cool. So consider that, and I know a lot of people get triggered. They're like, no, I want to do an engine. It's what I want. This is the only car I ever want to own in my entire life. Dude, like, you know, relax. So there's a time and a place for engine swaps, as in trying to make this old, awesome Indy car chassis viable with a Honda K-Series. Brilliant idea. Honda K-Series are used in other Formula ranks, even currently, in many different states. So we think it's going to work. Doing a Huyabusa engine and a crazy space frame Formula One build, great pairing, but a huge build. And throwing a giant Viper engine in the back of a huge mid-engine monster with a GTP body called the Jabberwock, that works too, but it's a heck of a lot of work. So just keep all those things in mind, guys, and I hope this was helpful. I don't have a Dorito engine or rotary to show you, but just give consideration to their spatial considerations of what they need if you're thinking about doing it. And have fun. But I hope you guys subscribe, because lots of crazy builds coming up, and I'll see you next time. Okay, I'm done. Thanks, guys. Huge shout out to KW Suspension. Guys, this year you're gonna see beautiful coilovers such as this going on many of my cars, including my Porsche 944, my Dodge Viper, and even some of these crazy race cars. And the reason is simple. This is one of the best shock companies in the world. It was founded in Germany in 1992 by Klaus Wohlfarth, and recently they just launched a new 1.2 million square foot robotic warehouse where they're creating unbelievably nice suspension components such as this for 15 different original equipment manufacturers. So whether you're a street enthusiast, a weekend track warrior, or you are building the Le Mans car of your dreams, guys, check out KW Suspension. Unbelievably nice shocks. So go down in the description below, patronize them. You're gonna be glad you did.